Okay, so we're going to continue on talking about inequalities right now, okay? We know how to solve inequalities using addition and subtraction, but we also need to learn how to solve inequalities using multiplication and division. Okay, so in order to illustrate the point, okay, let's first explore some things about multiplication and division. So I'll just put the multiplication sign and the division sign here. All right, so let's start with a statement that we know is true. Let's say 3 is greater than 2. Is that a true statement? Yes. We know that that happens to be true. If I have $3 and you have $2, well, then I have more money than you. Okay, so 3 is greater than 2. All right. So what I'm going to do now is I'm going to multiply both sides by a number that is not 0. Okay? So I'm going to multiply by the number 5. Okay? Multiply by the number 5 and multiply by the number 5. And what statement do I have left over? What do I get? What do I have on the left-hand side now? I have 15 is greater than what? 10. Is greater than 10. Okay, so I still have a true statement. So if I multiply both sides of an inequality by a positive number, then my inequality still holds true. Does that make sense? Okay, so let's explore why this actually works on the number line. So what does this mean here? So, okay, so here's the number 0, okay? Here's the number 2, here's the number 3, all the way over here is the number 10, and all the way over here is the number 15. Okay, so if I have the number 2, I have the number 2, right? And then I multiplied it by 5, well, that bounces me over here to number 10, okay? So far, so good. But if I have the number 3, which is still greater than 2 to begin with, and I multiply it, notice it bounces me even further away to the number 15. So the inequality still holds true. Why do you suppose I'm looking at it this way? Why do you suppose I'm looking towards the number line for this? Anybody know where this is going? What's going to happen when I multiply by a negative number? It's going to bounce. Yeah, what does it mean? Yeah, what does it mean? How do I graph the number negative 2? On here, what does that mean to do? Yeah, I'm going to go to the left, right? Okay, so if I want, like, to say the number negative 2, for example, right? So you could think of a number and its opposite as being reflected over the point 0. Is that true? You ever thought about it like that way? Oh, no. Okay, so think about it, right? If I have the number, let's say 2, okay? And I want to graph the number negative 2, well, it's the same distance away, just in the opposite direction. So it's like a little mirror, right? Think about it like that. So if we think about it that way, the next part of my argument makes a little bit more sense. So in general, if I have A, which is greater than B, okay, and I multiply by a number C, which is greater than 0, so if I multiply by a number C greater than 0, all I'm saying is that those numbers are positive, right? If C is a number bigger than 0, then it has to be a positive number. Do you guys agree with that statement? Okay. So if this part is true, then I know that this statement is still true. A times C will still be greater than B times C. So this is kind of like my first little statement that we have that we've been explored by. Okay. All right. Let's start this whole process over and let's talk about something with negatives here. So let's start with a statement that we know is true. Let's start with this. How about 5 is greater than 2? True? Everybody agree with that part? Yeah, 5 is greater than 2. Okay, now, so I'm going to multiply by a number that is less than 0. So a negative number. And I'm going to make it really, really easy. I'm going to multiply both sides by a negative 1. Okay? So what do I have left over here now? What do I get? I get negative 5 is greater than negative 2. Is that true or is that false? That's a false statement, okay? That's not true. That's a false statement, okay? So this is false. So how do I make it true? What do I have to do? I have to flip the direction of the inequality. So negative 5 is now less than negative 2. So this is what I have left over. So the thing I'm getting at is that, everybody always says, why do you always have to flip the sign when you multiply or divide by a negative number? And it really comes back to just looking at where things are on the number line. So as an example, right, let's put 0 right here. And then let's put the number 2 right here. And let's put the number 5 over here, okay? So And then if I do a reflection, right, here's negative 2, and then over here, here's negative 5, okay? So I started with the number 2, right? If I multiply it by a negative 1, so it's going to bounce me over here. You guys agree with that part? Okay. If I start with the number 5 and multiply it by a negative 1, it bounces me over here. So if I think about the opposite of a number being the reflection over the point 0 on the number line, well then my inequalities have to adjust for where my new location is. Doesn't that make sense? So this is a really simple explanation as to why we have to reverse the direction of the inequality, right? When I take the opposite of a bigger number, it's further away from 0 than the other number is. Does that make sense? I take the opposite of the bigger number. So I bounce it over, it's further away. So that's why we reverse the direction of the inequality sign, right? I don't want to just tell you something without kind of explaining where and why it comes from. So in general, here's the rule that we have, right? If we start with A is greater than B. So in general, A was greater than B. Now I'm going to take a number C that is strictly less than 0. Strictly less than 0. I'm going to multiply it by both sides, so a negative number. So then I end up with this. I end up with A times C is now going to be what? Less than B times C. So I need to reverse the direction of the inequality sign. Whenever we multiply or divide an inequality by a negative number, we reverse the direction of the inequality sign, and the reason is thinking about reflecting points over the point 0. Okay, let's solve this one together. X divided by 3 is less than negative 2. Okay, what's a good idea? What should I do to both sides? Evan, what do you think, buddy? Anybody, yeah, over on that table, yeah.
You can multiply both sides by 3.
I'm going to multiply both sides by the number 3. I'm going to multiply both sides by 3, okay? 3 divided by 3 is the number 1. 1 times anything is just anything. So I'm going to have X is now going to be strictly less than negative 6, and we can easily draw that on the number line. Here's 0, here's negative 6, here's an open dot, and I want to go to the left, and I should put arrows on both sides. Notice I did not change the direction of the inequality sign. How come? What's the reason for it? Why did I not? Because I did not multiply or divide by what? A negative number. I did not multiply or divide by a negative number. Let's do another example together, okay? Everybody, let's do example B. Let's do X divided by 8 is greater than 1/4. X divided by 8 is greater than 1/4. Okay, Brandon, what's a good idea here? What should I do to both sides of the equation? Multiply? Both sides by 8. Yes. Why? There's a very good reason. Why should we multiply both sides by 8? Anybody can answer that question. Why multiply? Yeah.
To get x by itself.
Yeah, to get x by itself. But how come I didn't subtract 8 from both sides?
Because it's not multiplication.
What's the inverse of division? Multiplication. That's what we mean. Okay. The inverse operation. So I'm multiplying. Okay. 8 divided by 8 makes 1. So I'm getting x is now strictly greater than 8 divided by 4 is 2. Here's the number line, here's 0, here's the number 2, here's an open dot, and we're going to the right, and I should have it open on both sides. Okay, we're going to solve and graph this one. Negative 3/4 x is greater than or equal to 3. All right, what should I do? Who's got a good idea? Will, what do you think, buddy?
Multiply both sides by. Is it 4 or just 4?
I could do that. I could do that. There's a faster way to get to the answer, but I could do that. Well, there's nothing wrong with that. What do you think?
4/3.
Multiply everything by 4/3, but I could even go one step further. Multiply it by what? Negative 4/3, right? Negative 4/3. Multiply both sides by negative 4/3. Okay, let's talk for a moment. Why are we choosing negative 4/3? Anybody see that one? It's the reciprocal of 3/4, right? And it's negative because I know two negatives multiplied together make a positive. Okay, so therefore, on the left-hand side, I'm just going to be left with x. But since I am multiplying an inequality by a negative number, we know to reverse the direction of the inequality sign. We discussed that in box number 1. And I'm left with x is now less than or equal to negative 4. You guys see that? Because the 3's cancel out. Okay, good. So then when I graph this on the number line, I'm going to have 0 over here. I'm going to have negative 4 here. I'm going to have an open dot. I'm going to color that dot in, and I want to graph to the left. And then this is how I make my graphs. Okay, try this one in your groups. Please solve and graph. Ready, set, go. Okay, Alice, what'd you do?
I divided by -9.
Divide both sides by -9. Yep, okay, good.
And then you flip, you flip it to y is greater than or equal to, and then you get -7.
-7, absolutely. Y is greater than or equal to -7. So here's -7. There's my 0. I want everything colored in, and I want everything to the right. Okay, everybody feeling good about this now? Yes. All right. Okay, so kind of the same thing here. We're going to do a little more examples. 9 plus 4x is greater than 21. Okay, Brandon, what's a good idea? What should I do first, buddy?
Okay, you can divide by 4.
I don't want to do that first.
You can subtract by 9.
I can subtract 9 from both sides. I want to subtract 9 from both sides. I want to do that part first. Okay, so 4x is still greater than, okay, 21 take away 9, how much is that worth? That's worth 12 every single day, right? Absolutely. Okay, Will, what's my next move, buddy?
Then you divide by 4.
I'm going to divide both sides by 4. You're absolutely on the right track. So x is now strictly greater than, how much is that worth? 3, and that's not really a big deal. Notice that we did not change the direction of the inequality sign because nowhere in our process did we multiply or divide by a negative, right? So if I'm going to graph that on the number line, I'm going to have 0 over here. I'm going to have 3 over here. Is my dot going to be closed or open? Open. How come?
Because it's not equal.
It's not, there's no equal part. You guys are doing great. Absolutely. Okay, 2 examples in one here, solving graph both. Okay, let's do part A together. It says -6x minus 7 is less than or equal to -17. Okay, Alice, what's my first move for part A there? What do you think?
Add 7.
Add 7. You're totally right. Let's add 7 to both sides. I agree with that. Perfect. So I'm going to get -6x is now less than or equal to 7 and 17. How much is that worth? 24. Yeah, 24. Good. Okay. Next move, Isabel. What do you think my next move is going to be now?
Divided by
Divide by -6. You are absolutely correct. Let's divide by -6. Okay. If I am dividing an inequality by a negative number, Luis, what do I need to remember to do? If I'm dividing an inequality by a negative number, what do I have to remember to do to the inequality sign? I have to reverse the direction. So now x is going to be greater than or equal to 24 divided by -6. How much is that worth? That's worth -4. Very good. So if I graph this on the number line, I have 0. I have -4 to the left of 0. I have an closed dot because it is strictly, it's greater than or equal to, excuse me, and I shade that way. Okay, example B. Daniel, what's my first move, buddy? Subtract 30 from both sides. That's a good move. I like that. So 50 take away 30, how much is that?
20.
That's worth 20. So 20 is greater than 0.8x. Okay, my next move. Will, what's my next move?
You divide by 0.8.
I divide by 0.8 on both sides. 0.8 on both sides. Okay, who can do that for me? 0.8 on both sides. 25? You guys get 25? Yeah, you can use your phone for that. So 25 is now greater than x, okay? How should I rewrite that? How should I rewrite that if I want to graph it? Paul, what do you think? Less than 25, okay? Do you guys see that those two statements are the same, right? 25 is bigger than 10. 10 is less than 25. There's two ways to say the exact same thing. So if I'm going to graph this on the number line, I'm going to have 0 here. I'm going to have 25 way over there. I'm going to have an open dot, and I want everything to the left because it's strictly less than. I prefer, again, to have my variables on the left-hand side to match my direction of my graph. All right, so now we have a more complicated inequality, but nothing that we can't handle. It says 3 times the quantity x plus 1 minus 4x is greater than or equal to a -5. All right. Well, the first thing that we should probably do is distribute our 3 into our quantity of x plus 1. All right. So that's going to give me 3x plus 3 minus 4x is greater than or equal to -5. Is everybody cool with that part? Okay. What's my next move now? Will, what do you think, dude? Next move.
Oh, you combine like
Combine the like terms. Which two terms are the like terms?
3x
3x
and negative 4x.
and negative 4. So how much does 3x take away 4x?
Negative.
Negative x. Good. Negative x plus 3 is greater than or equal to negative 5. Okay, next move.
Subtract the 3.
Subtract the 3. Very good. Subtract 3 from both sides. So I'm getting negative x is greater than or equal to negative 8. All right, am I done? No, I'm not done. What do I do now? I divide by, yeah, negative 1. Exactly, divide by negative 1. So now x is less than or equal to a positive 8. Because I am dividing by a negative on my inequality statement, I need to reverse the direction of the inequality sign. So therefore, when I graph this all together, all right, here's my 0, here's my 8, here's my dot is closed, I'm going to the left, and I'm coloring all that in. Okay, here you go. It's a U try for you in the table. Big, huge green markers right there. 6x minus 1 is greater than 3x plus 8. Go ahead and solve it and graph it, please.